Okay, so on this question, it says one inlet pipe can fill an empty pool in 8 hours, and a drain can empty it in 10 hours. How long will it take the pipe to fill the pool if the drain is left open? Not a good plan, right? You don't want to fill the pool with the drain left open. But technically you could, right? How do we know we can? Well, because it fills up faster than it drains, right? It can fill in 8 hours. It drains in 10, which means the filling is a little faster. You can fill the whole pool in 8 hours. And whereas it take longer to drain. So the filling's faster. I don't think that's normally how things work. I think usually draining is faster, actually. But anyway, we're doing a little pretend scenario, I guess, here. All right. So anyway, how are you going to do this? Well, you guys know what to do, right? If it takes 8 hours to fill the pool, then what portion of the pool gets filled every hour? 1/8, huh? Does that make sense? If that pipe, that inlet pipe, can fill the whole pool in 8 hours, then every hour it gets 1/8 of the pool filled, doesn't it? Minus. Why minus? Because the drain is taking it back out, right? Minus 1/10, right? Because the drain can drain the entire pool in 10 hours, which means every hour it takes out, subtracts away 1/10 of the pool, doesn't it? And that's going to equal, they're asking how long will it take to fill? X is hours to fill the pool. So that's going to be 1/x. Does that make sense? So we're basically saying 1/8, that's the amount of the pool filled in 1 hour, minus 1/10, that's the amount of pool drained in an hour. And 1/x, that's the total effect in 1 hour, right? If it ends up taking X hours to fill the whole pool, say that's like 30 hours. It's going to be a lot of hours. It's going to be a slow way to go. Say it takes 30 hours to fill the pool, then this would be 1/30 of the pool getting filled every hour. So that's why that makes sense. So there's our equation. So whenever we have working together, this is basically a working together problem, except they're not working together. They're kind of against each other. It's 1/A plus or minus 1/B is 1/together. That's how we do these. Plus if they're helping each other, minus if they're opposing each other, right? I put plus or minus. So there we go. So that's what we need to do. There's our equation. Let's solve for X now. Now, how do you do this? Well, you know, this is a rational. So this is a rational. Rationals with an equal sign. How do you handle rationals with an equal sign? Step number one, you multiply by all the terms, left and right, by the LCD over 1. And what's the LCD? Well, technically the LCD is 40x. I'm not really using the LCD, but because I found it's easier for students to just take one of every denominator item. So I'm just going to use 8 times 10 times that. 8 times 10 times that. 8 times 10 times that. Again, technically that's not the least. That's not the lowest. That is a common denominator, but that'd be 80x. The lowest one's actually 40x, but this will work fine. I think it's easier. I found it's easier for students over the years. All right, so then step 2, cross cancel and multiply the leftovers. Let's cancel, multiply the leftovers. So 8 cancels 8. What are we left with? 10x. And this kind of going wonky here. Here we go. Whoops. So 10x minus 10 cancels 10, 8x, and x cancels x, and we're left with 80. 8 times 10, 880. Does that make sense what happened there? So I cross cancel. So we always do when we have an equal sign with fractions. We multiply by the LCD, which takes out the denominator and multiply what's left over. Take it out, multiply what's left over. Take it out, multiply what's left over. And this is easy. 8x, 10x minus 8x is 2x, is 80. And then solve for x divided by 2. X is 40. It's going to take 40 hours to fill the pool that way. Not a very good plan. 40 hours to fill the pool. There we go. And if you get a by the way, if you got a decimal answer, give them at least, just give them 3 decimals. It says 2 or more. Give them 3 decimals. You're fine if you happen to have decimals. There we go.